All right, so here we go. Number 28. It says, whoops, hold on. It says you are given all three angle measures for a triangle. Explain why the triangle cannot be solved. All right, so the reason for this is because if you're given the three angle measures, what it means to solve a triangle, it means to find all of the side lengths as well. So let's say this looks like what, maybe 50 degrees. This looks like maybe 100 degrees. And that would mean this would have to be 30 degrees, right?
Mm-hmm.
You understand that? Because they all add up to what?
100,
What do all the angles of a triangle have to add up to?
180.
That's right, 180. But imagine this right here. If I just give you the angles, look, I can take that and make it bigger. I can make the same triangle, but just make it bigger. This is 50 degrees. This is 100 degrees. And this is 30 degrees. Right?
Mm-hmm.
Does that tell you anything about the side lengths, what they have to be?
No.
It doesn't. So this said you are given all three angle measures. If you're given the three angle measures, you can't solve for the sides because these triangles are only similar triangles. Similar triangles are proportionate, but not congruent, but not necessarily congruent. Congruent would mean that the side angles or the sides are equal.
Okay.
Proportionate means that the ratio of sides are the same.
All right.
Proportionate means that the ratio of sides to sides are the same. You understand that? Congruent means that the sides are equal.
Yes.
Okay, so that's the reason for that one. Make sense?
Yeah.
All right, page 2. You see my screen okay?
Yeah.
All right, this says write a problem that can be solved using trigonometry and an understanding of angles of elevation and depression. Draw a picture and solve the problem. All right, so you can, let's see, what kind of word problems have you seen that are related to this?
I don't know anything about it.
You've never seen any?
No, not really.
Okay. All right, so let's do it like this. Let's say that I'm gonna draw the picture and you can write the problem out, okay? Or you can explain the problem. So the picture is you're 50 feet away from a light pole. Okay. So you're 50 feet away and let's make it really tricky. And let's say you're pretty tall. Let's say you're 6 feet, you're 6 feet tall. Okay.
Okay.
And the angle of elevation and I'm going to say you're 6 feet tall to your eyes. It's 6 feet from the ground to your eyes. And the angle of elevation when you're looking up at the light pole or at the light, the angle of elevation is 35 degrees.
Would the angle of depression, would that be the opposite? From the
The angle of depression, when they use that word, this would be your angle. If you were looking down from here, that would be your angle of depression.
Okay.
So this is what's called an angle of depression. Have you seen, it seems like maybe you have seen these. Angle of depression, and this is called an angle of elevation.
All right.
And you see how they're kind of equal to each other because these are parallel lines.
Mm.
So that's why they're equal to each other. If you draw a line that's parallel to the ground out from the person and he's tilting his head up, looking upward, that's an angle of elevation. And if you're up here, standing up here, and you're looking down, again, here's where the point of vision. You kind of draw a parallel line out from there, and then that's your angle of depression right there. You just have to make sure you have to read the word problems carefully to know where you're looking at and if they're talking about an angle of depression or an angle of elevation, or you just have to make sure you draw the picture right, because sometimes the angle you want is this angle right here, which would be 65, right? But we don't need that right now. We don't need that. All right, so it says write a problem that can be solved using trig and an understanding of angles of elevation or depression. So here's my picture, and the question is going to be, how tall is the light pole? So that's the question. We're going to call this X.
All right.
Okay.
Mm-hmm.
So the way you would, and then it says to solve the problem as well. All right. So we're going to solve it like this. First of all, this is a tricky problem because I'm going to have to draw this line right here, and I'm going to have to call this 6 feet right here. So let's make this distance right here, let's call this distance Y. The distance from there to there is called Y. Got it?
Right.
Does that make sense? And so X over here, I'm going to have to add 6 to Y to get X. X equals Y plus 6. Got it? Because it's the total distance to the top of the light bulb.
Right.
Make sense?
Mm-hmm.
Okay. So this triangle right here is a right triangle. You see it?
Yeah.
And I have 50. I have this side, which is what? And I have this angle. And what is this side in relationship to this angle?
It's the in relationship to this angle. It's the longer leg.
Okay, but it's either the hypotenuse, the adjacent, or the opposite.
The adjacent.
Very good. So this is the adjacent. And what is it that I want to find? What's the Y?
Opposite.
Good. This is the opposite. So what trig function relates adjacent and opposite?
Cosine.
Nope.
Oh, okay.
It's so ka toa.
Oh, okay. All
You
right.
see the OA opposite adjacent, that's your tangent.
Okay.
Do you get it?
Yes.
So tell me what the tangent of 35 equals.
Oh no. I don't
Write
know.
the equation out. Look up here in the upper right. The tangent is equal to what?
The adjacent.
No, look up here. Let me make it. Have you heard the phrase SOHCAHTOA?
Yes.
Okay, see how I'm putting those slashes in there?
Oh, is it okay? It's the
The
opposite.
tangent equals the opposite over the adjacent. Okay, so tell me what to write. Tangent equals what?
Um, Y over adjacent, I guess. Y over
And what's the adjacent again?
50. Okay.
Good, you got it. 50. So that means Y equals what?
Um, equals 50 times 35.
50 times the tangent of 35. Now I'm going to open my calculator. Make sure you're in the right mode. You got to be in degrees, right? Make sure your calculator's in the right degree or the right mode. So it's 50 times the tangent of 35 degrees. And hit enter. And there's your answer, 35.01. So equals 35.01 feet. So how high is that light?
It's 41.101 feet.
Yep, so I'm gonna add 60, so X, I'll write this over to the right. X equals 35 plus 6,
Yeah, 41.
which is 41-ish. So that's how tall that light post is.
All right.
Okay, got it?
All right.
So you can write the word problem out. Now that I drew the picture, you can write the word problem out. So what you should say is, a man is standing 50 feet away from a light post. The angle of elevation from his eyes is 35 degrees. His eyes are 6 feet from the ground. How far or how tall is the light post?
Yeah. I see.
Okay, so vocabulary. What's the difference between sine of x and sine inverse of x? Well, this sine of x is a ratio. Sine of x is a ratio of side lengths. It's a ratio of the opposite to the hypotenuse, right?
Right.
And sine inverse of x is the angle whose sine is equal to x.
I see.
Do you see the difference between those?
Yeah.
So it's like they're the inverses of each other.
Right.
It's like saying, what's the difference between the square root of 9 and 9 squared? What's the difference between them? They're totally different things. This is the number when you multiply it by itself, it equals 9. And this is the number when you multiply 9 by 9 that equals.
All right.
So these are like inverses of each other. I don't know if that was a good explanation or not, but that's kind of like what it is. Totally different thing. The difference between that example and what I just gave you is, for these, this is just a number right here, or a ratio, and this is an actual angle. So the units are totally different. Do you get what I'm saying?
Yeah.
This is like a ratio of side lengths, and this is an angle in degrees or radians. So they're totally different. Okay.
We don't need to necessarily do all of these problems. Maybe just do the first two or something.
I think we can probably get through most of them. Find the values of x and round to the nearest tenth. All right, so we have the answers. Nice. I like that, how you got that. So let me show you how you're going to find them. Well, when we have, see how these aren't right triangles?
Yes, there.
These are right triangles, and that's, by the way, these are called oblique triangles. Oblique means not right. Not right triangles. So we don't use SOHCAHTOA.
Okay.
SOHCAHTOA is used for right triangles. What we need to use is the law of cosines or the law of sines. Got it? So
Right.
this is used for right triangles, like we just did. And for oblique triangles, we need to use law of sines or law of cosines. Have you learned these yet?
No, not really.
Uh-oh. All right, so here's the law of sines. You ready? I'm going to write these down here. Law of sines. I'm basically teaching you like a week's worth of material in 5 minutes. So you ready for this? The sine of A divided by A equals the sine of B divided by B equals the sine of C divided by C. And that's if you have a triangle that looks like this. A, B, C, A, B, whoops. I did that wrong. B, C, A.
Okay.
So you see how the angle across the angle and the side across from it are labeled with the same letter.
I see.
Capitals are degrees, lower cases are side lengths.
Yeah.
So the law of sines says that the sine of an angle divided by the side opposite from it is equal to the sine of another angle divided by the side across from it. That's the law of sines. So
Yeah.
look at this right here. See how I have a side? I have a side and I have an angle. Find this angle, right?
Mm-hmm.
It's going to be 180 minus 52 minus 28. 180 minus 52 minus 28. Whoops. Whoops. Let me try that again. 180 minus 52 minus 28. So this is just 100. Got it?
Right.
So the sine of 100, watch my formula. The sine of 100 divided by 48 is going to equal what?
X.
Don't write X. Look at the formula down here.
Oh, I see.
So the sine of this angle divided by the side across from it is equal to what?
Sine.
The sine of another angle
Sine of another angle.
divided by what?
52.
The sine of 52 divided by, nope, not 52. This is the what?
B.
It's the side across from it, right?
Y.
That's right. So now how do I solve for y? Do you remember the? Do you remember the?
Minus 100 minus 28.
So let me. I don't know how well you are at how good you are at algebra, but how do you solve a proportion like this?
You multiply the sides.
You cross multiply.
Cross multiply.
Remember that?
Yeah.
So it's sine of 100 equals 48 times the sine of 52, right? And so what does y equal? How do I get rid of this?
You divide sine and
Divide sine of 100. So this over sine of 100. And make sure you're in degrees, which I am. So look at the calculator. 48 times the sine of 52. I just hit enter. I would just hit enter and then divide that by the sine of 100. So there's your answer for y. So y equals 38 point nearest tenth, so 38.4. Now to find x, what should I do to find x?
I don't know.
Well, look at how I found y. I set up a proportion using the law of sines. Can't I do the same thing for x?
Right, yeah.
Instead of sine of 100 over 48 equals this, it would be sine of 100 over 48 equals what?
A.
Sine of 100 over 48 equals, tell me what to write.
Sine 28.
Good. Sine of 28 over
X.
x. Good. So what does x equal?
Um,
It equals 48 sine 28, right?
yeah.
Divided by sine 100. Get it?
Mm-hmm.
So here we go. 48 sine 28. And I can just do divided by sine 100. Hit enter. 22.9. Now, does that look roughly correct to you?
Yeah, say so.
Yeah. Why? Because look at the biggest angle is 100 degrees, and it's across from the biggest side.
Oh,
That's why. See
right.
this, the medium angle is across from the medium side. The smallest angle is across from the smallest side. Okay?
Okay. Mm-hmm.
That's how these things work.
Okay.
So let's try number 24 and see if we can do that one now. Now, for number 24, the problem is, what's the problem on number 24?
It's lopsided.
I don't have any of the angles. So can I use the law of sines if I don't have any of the angles?
No.
I can't. So I have to use what's called the law of cosines. This is a little bit trickier of a formula. It's not quite as simple. And in fact, I have to kind of look it up because I don't have it. I kind of have it memorized, but I'm not always correct. The law of cosines is like, let me see if I get it right on my first try. A squared equals b squared minus c squared plus bc cosine a, or something like that. Let me see if I got it right. I'm going to look it up. Can you still see my screen?
Yeah.
I'm teaching you how to look up stuff. Law of cosines. You can see that I was watching the Players Championship. Law of cosines. A squared equals, oh, it's 2bc and it's minus. So, oh, and it's squared. My bad. I was pretty far off. So it's a squared equals b squared plus c squared. Here it is. Here, let me take a picture. Let me take the picture and put it in. Okay. So let's see. I'll drag that in here so you can see it. That way it'll be easier. I shouldn't have tried to do it off the top of my head because it's been a while since I've used it. So let's add this from the images. That's not what I meant to do. Let's add this from my image library. Huh, it's weird. Didn't think I did it like that. Didn't I take an actual screenshot of it? Huh, it's weird. The screenshot didn't save. I wonder why. Let's try that again. Do you see the law of cosines? Done. Save to photos? Save to files? Is that what I should have done? Okay, we'll call it that. So I should have saved it to photos too. Let's see, photo images. Oh, image library. That's where I should have gone. Image library. Okay, there it is. I don't know why it took so long for it to show up. There's my law of cosines. Okay, nice. And see, now the reason that we have to use law of cosines is because we don't have one of the angles, so we can't use this formula. If we don't have at least one of those angles, we can't use the law of sines. So if we only have the three sides, or if we have two sides and the angle between them, like this, you'd have to use the law of cosines. So for number 22 and 24, you have to use the law of cosines because you have either what's called side, angle, side. Use the law of cosines, or you have side, side, side. That means you have to use the law of cosines. But if you have at least one angle side across from it, which I do right here, do you see that? See, I have an angle with the side across from it. I can use the law of sines for these ones. Okay, so that's how you know which one you need to use. Now the law of cosines is a little bit trickier to use because what you're going to have to do is plug in all of those things into the equation and then solve that equation. Are you good at doing that? Are you pretty good at algebra?
I guess plugging things in, sure.
Well, let's find out. I'm going to do this. Let's call this A. Let's call this B. Let's call this C. Okay? And we're going to use this first formula, the A formula up there. You can use any one of them. So ready? We're going to go 42 squared equals 64 squared. What should I write now?
58 squared.
Good. Minus 2 times, what should I write?
64 and 48. 64,
64, good. 64 and 58 times the cosine of A.
42.
All right, so the cosine of A, remember, I'm trying to solve for A. Actually, that's going to be the cosine of Y, right?
Oh, I see.
Right?
Right.
Okay, because I was using 42 as my A. So I'm solving for this one right here. So I'm going to have to punch this into my calculator. I'm going to have to go 42. I'm going to write this over here to the left so I can see it better. I'm going to have to go 42 squared minus 64 squared minus 58 squared, all divided by -2 times 64 times 58 equals the cosine of Y. Right?
Right.
Then, on top of it, I have to take the cosine inverse of that in order to solve for Y. So that's going to be what my Y equals. Did you follow how I did that?
I guess.
I did. Just take a look at this because I did it kind of quick. I subtracted this, then I subtracted this, and that. Then I divided by this. That's all being multiplied. Divided by the negative that mess. Got it? And then to get rid of the cosine, I took the cosine inverse of that whole mess. But watch, you can actually plug that in exactly how you see it. So I'm going to type cosine inverse, and then I'm going to put parentheses around this that I'm putting in the top. 42 squared minus 64 squared minus 58 squared. So that's my numerator. Divided by, I'm going to put parentheses around this to make sure they all stay together. -2 times 64 times 58. And there's my answer.
39.
So that's the degrees, right? That's 39.9 degrees is what X equals. Or Y rather, Y.
All right.
Okay. Now, what should I do to find X now?
You have to do the C squared, that equation.
I could do that, or now that I have Y, what could I just do?
Oh.
use now that I have y?
Oh, you could do you could do a sine.
Couldn't I do the law of sines now?
Oh yeah, you could.
That's what you do. So the law of sines, now that I have that angle, I can say the sine of 39.9 divided by 42 is equal to the sine of what?
30 of y. No,
The sine of x
x.
divided by what?
Um,
Look at the
50,
side across from x. What's the
58,
side across from x? 58, right? Got it?
right.
Okay. And now how do I solve this one for x?
You how do you solve this one for x? You multiply by 40. You cross multiply.
Good. Cross multiply. So 58 times the sine of 39.9 equals 42 times the sine of x. Now what?
You multiply by, you divide, I think, by sine 39.9.
No, because remember, I'm trying to get x by itself here, right?
You
So I
divide,
shouldn't divide by this. I should divide by this,
oh,
right?
right.
And now how do I get rid of the sine to get x by itself?
You divide by it.
You can't divide by sine. What did I do over here to get rid of the cosine?
Oh, you inverse it. You invert it.
You cosine inverse it. That's why that's why they have that function. So what I do is I take the sine inverse of that mess there, and that'll get me x. Got it?
Right.
So I can do that all in one step. Sine inverse of 58 times the sine of that thing that I had all over 42. So it's sine inverse of 58 times sine of 39 times the sine of 39, which was my answer. So I'm just going to click answer. Sine of answer. You know how to use that trick?
Right.
Divided by 42. Let's make sure I did all that right. I think I did that right. Hit enter. 62.33. That seem about right?
Oh, you just get rid of the 42. Okay.
62.3 degrees. Does that seem about right?
I guess.
62.3 degrees. And again, how do you check your answers? Your answers, because does it kind of make sense? If this is 58 and this is 42, does it make sense that the side across from, or angle across from it, would be 62, whereas the angle across from this is 39, like 40? Does that kind of look like it kind of makes sense?
Sure.
It does. So I feel pretty good. Hey, what if they wanted me to find this angle here? Would that be hard now?
No, you could just subtract. Right. You just subtract
Perfect.
these from one.
Good job. Good job. Awesome. All right. Well, hopefully that helps. I know that was, you have a lot of questions and it's going to take some time, but if you're going to come tomorrow to the in-person tutoring, that'll give us a lot of time to practice because it's a 90-minute session tomorrow. Okay.
Thank you.
So I will see you. Hopefully I'll see you tomorrow. Okay, bud?